So in 8.5, we're going to be talking about rational functions, which are functions that have x's in the denominators. Okay. And we started talking about the first characteristic that we're going to talk about is the domain of rational functions, which is what we ended up with last week, that 5.1 or 5.4. I think it's 5.1. Talking about the domain of rational functions. That's what we're going to start off with today in 8.5. Okay. The first one tells us to determine the domain of the function. And remember, when you have an x in your denominator, that means there's going to be a restriction in your domain. There's going to be a value or multiple values that need to be left out of your domain because they would turn the denominator into 0, which is what you can't have in your denominator. So on number 1, the function is f of x equals x squared over 9 minus x. And we're asked to find the domain. Now remember, it all has to do with the denominator. Your denominator cannot equal 0. So set it up to not equal 0, and then just solve it like you would any other equation by getting the x by itself. So subtract that 9 from both sides. So now I'll bring down the negative x. Can't equal 0 minus 9 is negative 9. Now I need to turn this x positive. So I'm going to divide both sides by negative 1 to turn this x to a regular x. So x cannot equal this negative over a negative, turns that into positive 9. Okay. Now, just like last week, it's going to want you to write this in its interval notation. So what I want to show is on the number line, x can be anything from negative infinity to positive infinity except 9. So I want to show in intervals all the numbers on the number line excluding that 9. So this interval is just like it shows right here, negative infinity to 9. And then the numbers above 9 would be, you'll use that little u that's down in the toolbox in Math Lab in union with positive 9 to infinity. So that would be the domain of that function. All the numbers but 9. All right, number 2. Same kind of problem asking me the domain of a rational function. Okay, so this one on number 2, the function is f of x equals 3 over x squared plus 2x minus 35. All right, so again, the denominator cannot equal 0. But this time in my denominator, it's an x squared. Now, if I'm trying to find the solutions of something that starts off with an x squared, I can just go straight to my quad program, okay, and let it do the work for me. So you just would go to program. I'm going to do it without the program also. So down to quad. Enter your a, b, and c. So remember, your a is in front of x squared. So my a would be 1. My b is in front of the x, so it's positive 2. My c is my constant, which is negative 35. So if I enter those into my quad program, 1, let's see, 2, and negative 35. So 1, 2, and negative 35. There's the solutions, 5 and negative 7. Okay, so if I didn't have the quad program, then I would have to solve this by factoring, putting it in its factored form. X and x for x squared Then I'd have to say, okay, now I need the numbers that multiply to equal negative 35 and add to equal a positive 2. So let's see, I'm going to use the numbers 7 and 5. They have to multiply to negative 35 and add to positive 2. So when you're multiplying to equal a negative, you know you have to have a positive number and a negative number. If I'm going to manipulate my signs so that when I add these two together, it ends up positive 2 instead of negative 2, that means my 7 needs to be positive and my 5 needs to be negative, right? You need more positive if you're going to end up positive. So there's my factors. What do you do with your factors? Set them equal to 0 and solve them for x. So this one, I'd have to add the 5 to both sides. So x equals 5. And this one, I'd have to subtract the 7 from both sides. So here, x equals negative 7. So those, just like I got in the quad, right? You're solving the same thing. That's why you're getting the same answers. So if I'm entering this in interval notation, let's think about the number line from negative infinity to positive infinity. What numbers am I leaving out? 5 and negative 7. But when you were doing interval notation, when you put these numbers on the number line, they have to be in the right order. So if I'm coming up the number line, who am I going to run into first? A positive 5 or negative 7? If I'm coming this way, the negative 7 will be there and the 5 will be there. Now you've got 3 separate intervals that need to be represented. This first interval will be just like the number line says, negative infinity to negative 7. And this middle interval will be negative 7 to 5. And the last interval will be this last part of the number line, 5 to positive infinity. Okay, we're going to come back to number 3. We're going to skip it, but come back. Okay, so on number 5, the next 5 through 10, we're going to be finding what's called vertical asymptotes. Okay, these rational expressions can sometimes have what's called vertical asymptotes. And the way you find them, or what they look like, is represented on paper. The vertical line is the one that goes straight up and down, right? A vertical asymptote is represented by a dashed line on paper. So you may have 1, you may have 2, it just depends. That's what it's going to look like on paper. The way that you find the vertical asymptote, this is one of the things that's in your 8.5 notes. The first thing is how to find the domain. And then the second thing is how to find vertical asymptotes, okay? Now, that's why I would print that sheet off so you can use it for this whole section. We're going to keep referring back to it over and over, okay? Your vertical asymptotes are also going to come from the zeros of the denominator, just like the restrictions in the domain did. But there's a disclaimer. The zeros in the denominator, as long as they're not zeros of the numerator, they're not also the number that makes the numerator 0, okay? Now, the first few that we're going to do, we don't need to worry about that disclaimer, okay? It'll make more sense when we get to a problem that has it. So let's look at number 5 and find the vertical asymptotes of this function. F of x equals 1 over x minus 4 squared. So I'm going to find the vertical asymptote. This right here, I set this factor equal to 0 and solve it for x, which means I will add the 4 to both sides. So x equals 4. What that tells me is that in this graph, if I was having to graph this or choose a graph that matches, that will go with this, there's a vertical asymptote going through the X at 4, just like that. So when you write it, it's already got the vertical asymptote is an equation because all lines have equations, okay? Its equation is always X equals whatever you got in that equation right there. It's just that number 3 already has, number 5 already has the X equals there for you. So you would just need to put in that 4. So that's how you find the vertical asymptote, by setting the factors in the denominator equal to 0 and solving them for X. All right, let's look at number 6, same kind of thing. F of X equals X minus 9. Over X squared plus 8X. So I'm finding the zeros of the denominator. It's X squared, which again means I can go to quad. Now, when you're going to quad, remember, you have to type in a number for A, B, and C. But when I'm looking here, I only see 2 terms, which means one of these is going to have to be a 0, right? I got to enter a number. So which one's missing? The constant is missing, right? The number that doesn't have a letter hooked onto it, which means your 0 is going to be that C. Because what's A? A is in front of X squared, which is 1. B is in front of X, which is 8. Again, I'm going to do it both ways. So go back to quad. If you're still in it, you'll just hit enter again, and it'll go straight to it. So my A is 1, my B was 8, and my C was 0. So there's the zeros, are 0 and -8. Now, also, I'm going to show you how I would have done it if I had to factor it. There's only 2 terms, but they both have an X, which means I would have pulled that X out, put in parentheses, what's left if I pulled the X out of X squared, I'd be having an X, plus if I pulled the X out of this, I'd have 8. So here's my factors. I would set them both equal to 0 and solve them for their X's. This one's already solved. This one, I'd have to subtract 8 from both sides. So X equals -8. So again, just like you got in your quad, 0 and -8. Now, this one I am going to check because the numerator also has an X. I need to make sure that neither one of these numbers here also is what makes the numerator 0. And they're not, because what in this place, what number, if you put it in place of this X, would make X minus 9 0? 9 would, right? 9 minus 9 is 0. Which it also, if I'm not ever sure, I just say, okay, I need to find out what makes X minus 9 0. You see that at all? So I would just set it equal to 0 and solve it for X. That would show me that X equals 9. So 9 is the 0 of the numerator. Okay, and the reason I'm doing it on this one is because once I find the zeros of the denominator, remember what the vertical asymptote rule is these are your vertical asymptotes as long as neither one of these numbers, which is 0 or -8, is the same as that 9 in the top. Okay, so that's why you got to check it. Right, number 7. F of X equals X minus 3 over 1 minus X. Again, we're finding the vertical asymptote, which means set the denominator equal to 0 and solve it for X. So I'd have to subtract the 1 from both sides. So I still have -X equals 0 minus 1 is -1. And then divide both sides by -1 to turn your x to positive. So x equals -1/-1 is +1. So that's your vertical asymptote because it's not also a 0 in the numerator, right? What makes the numerator 0? 3 would, right? 3 minus 3 is what would be 0. So since 1 doesn't, then that is a vertical asymptote. X equals 1. Right, number 8. F of x equals 3 over x plus 5, x minus 1. Okay, so on this one, again, I'm setting the denominator equal to 0 to find the vertical asymptotes, and they've already done the factoring for me, right? It's already in its factored form, so I can just jump straight to the step where I set my factors equal to 0 and solve them for x. So here I'd have to subtract 5 from both sides. So x equals -5. And here add 1 to both sides. So x equals 1. So those are your two vertical asymptotes. X equals -5 and x equals +1. Number 9. F of x equals x squared plus 5x minus 14 over x squared minus 3x minus 10. So I'm going to use quad, right? I'm finding the zeros of the denominator. So I'm going to use quad to do that. So my A, what's in front of x squared is +1. My B is in front of x, so that's -3. And C is my constant, which is -10. So 1, -3, and -10, which means the zeros of the denominator are 5 and -2. Which means my vertical asymptotes are x equals 5 and x equals -2, as long as the zeros of the numerator are not 5 or -2. So remember, I've got quad, so let's just go back to it and make sure that -2 or 5 doesn't come up in this answer also. So what's the A in the numerator? It's 1. B is +5 and C is -14. So here, those answers are 2 and -7. So no, neither one of those are the same as 5 or -2. So those are two true vertical asymptotes of that function. Right, number 10. G of x equals x to the third over 3x to the third minus x squared minus 30x. So I got to find zeros of the denominator to find the vertical asymptotes. Now, first thing is, I noticed that I have x to the third, so I can't go to quad yet. So, right, it has to be x squared. But look at all three terms. What do they all have? They all do have an x, which means I can pull out an x and put in parentheses what is left. X is just going to be my first factor. If I pull an x out of all three of these terms, they're all just going to drop an x. So let's see, this will turn to 3x to the second minus, this will just be x minus, this will just be 30. So now, this is a factor. I'll set it equal to 0 and solve it. And it's already solved. Once I set it equal to 0, there's nothing to do to get that x by itself. So one of the zeros is 0. Now I'm down. I need to find the other two. Well, now I am down to quad, right? Because my highest is x squared. So I can take what's left in there to quad. So go into quad again. This time my A is 3, my B is -1, and my C is -30. Okay, and when I hit enter, I get a crazy decimal, so I'm just going to hit enter again. There's the other two zeros, 10/3 and -3. So those would all be those are all going to be vertical asymptotes as long as none of these are also zeros of the numerator. Look at your numerator. It's x to the third. What number, when you plug it in for this x and raise it to the third power, is 0? What to the third power is 0? That would be 0, right? 0 to the third is 0, which means it's what makes it a 0 is the same as this one, which means this one cancels that one. That's what that disclaimer is saying on the vertical asymptote rule. All your answers down here are vertical asymptotes as long as they're not also the same thing as what would make the top 0. So your only vertical asymptotes are those two right there, 10/3 and -3. Okay, so far we've done domain and vertical asymptotes. Now we're going to do horizontal asymptotes, which are this is a horizontal line, and it's represented on paper by a dashed horizontal line. Okay, now it's a completely different ball game to find horizontal asymptotes. So I made you this chart on here. Okay, what you're going to be doing to find horizontal asymptotes is comparing the degree of the numerator to the degree of the denominator. Okay, so the degree is whatever the highest exponent is. So you're going to look for the highest exponent in the top. That'll be its degree. And then you're going to look for the highest exponent in the bottom of the fraction, and that'll be its degree. And then you're going to compare them. So here's what I would do. The important words that need to be underlined in this sentence is less than. In this sentence, I would underline greater than. And in this sentence, I would underline equal to, because that's what you're going to be, right? You're either greater than, or you're either less than, greater than, or equal to something, right? So you're going to use that chart to determine what the horizontal asymptote is, or where it is. All right, let's look at number 11. Determine whether this one's horizontal asymptote is. You have f of x equals 2x squared plus 5 over 5x squared minus 4. So go in the top and the bottom and circle the highest exponent. So the highest exponent up top is 2. Which means its degree is 2. The highest exponent in the bottom is also 2, which means its degree is 2. So when you're going to this horizontal asymptote chart, the degrees are equal to each other. So go to the one that says equal to, and let's see what that says about the horizontal asymptote. First of all, the horizontal asymptote is going to be in the form of y equals, because it's a horizontal line and not a vertical line. What does that tell me if the degrees are equal? The horizontal asymptote is the leading coefficient of the numerator over the leading coefficient of the denominator. So the leading coefficient is the number that's in front of this term. So it's 2. The leading coefficient of the bottom is 5. So you can essentially just think of this number right here is where the horizontal asymptote is. It's at y equals 2/5. That's what you do if the degrees are equal. Your horizontal asymptote is y equals this fraction right here. All right, number 12. F of x equals x squared minus 7 over 6x to the 4th plus 7. So the degree of the top is 2. The degree of the bottom is 4. So we're comparing the top to the bottom. Is this number? They're not equal, right? They're not the same number. This number is less than this number. So the degree of the numerator is less than the degree of the denominator. So that's where you go to your chart and you look for the less than, right? And if you had it written out, you have it underlined right there. What does that tell you? That tells you that the horizontal asymptote is automatically y equals 0. So when the degree of the top is less than the degree of the bottom, the horizontal asymptote is automatically y equals 0. Number 13. One more horizontal asymptote problem, and then we'll go back to number 3. F of x equals x to the 3rd minus 4x squared plus x minus 5 over x squared minus 20. So let's see, the degree of the top is 3. The degree of the bottom is 2. So what am I looking for? The numerator's degree is greater than the degree of the denominator. When you go to your chart, greater than is that middle one, right? That's the one where the greater than is. So what does it tell you? There is no horizontal asymptote. So that's what that tells you. If the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. All right, jumping back to number 3. Number 3 says R of x equals 3 over x squared minus 49. And I want you to list all the asymptotes. So let's do the vertical asymptotes first. And again, that's why I sent you these notes, so you can just refer back to them on how to find this stuff. The vertical asymptotes are zeros of the denominator that are not also zeros of the numerator. So let's see, I can either go to quad, or this is factoring by difference of perfect squares. X and X for X squared. Now remember, on difference of squares, these numbers are going to be the same number, and they're going to multiply to 49. So what's the same number? When you multiply it, you get 49, 7 and 7. And then the last thing is the signs. When you're doing difference of squares, your signs are automatically one positive, one negative. And then set these equal to 0. So X plus 7 equals 0. X minus 7 equals 0. And solve them for X. So subtract 7's here. So X equals negative 7. And add 7's here. So X equals 7. Those are both vertical asymptotes, right? I need to check to make sure those aren't also zeros of the numerator, but the numerator doesn't have an X, so I don't have to worry about it. So your vertical asymptotes are X equals negative 7 and X equals positive 7. Now on number 3, the second question is asking about the oblique asymptote. Oblique asymptotes are asymptotes that look like this. Okay, and we don't have any problems that are going to have that. So the answer to that part of that question will always be there are not any oblique asymptotes. And then the last part of the question says, okay, then what's the horizontal asymptote? And remember, look at your chart. What does the horizontal asymptote ask you to do? Compare the degree of the top to the degree of the bottom. So the degree of the top is 0 since it doesn't have an X. The degree of the bottom is 2. So numerator less than denominator. So when you go to your chart, your horizontal asymptote chart, and look at less than, the horizontal asymptote is automatically Y equals 0. So verticals at 7 and negative 7, horizontal at 0. So now we're going to have to choose this multiple choice. Let's look and see just what this part of the graph should look like, where the asymptotes would be. And again, the asymptotes are represented by dashed lines. So there's 2 vertical ones, the ones that go straight up and down. One goes through the X at 7. And one goes through the X at negative 7. So looking at your A, B, C, and D, that automatically knocks out B and C, right? They only have one vertical asymptote. So now these both have that at 7 and negative 7. 7 and negative 7, so I can't distinguish there. My horizontal asymptote is Y equals 0. Well, this is where Y equals 0, right here. That horizontal line. Okay, I still can't distinguish on A and D. It looks like they both have it. You can't tell because it's on the X-axis. Okay, which means just knowing these 2 things cannot pick out that graph for me. So I need to know something else, and this is what we're going to get into next anyway. I would try to find the Y-intercept, where it crosses the Y-axis. Remember, you can do that by looking at your original function and plugging in zeros for the X. If I plug in a 0 for this X, it essentially, when you put a 0 in an X, it just knocks out its term. Your Y-intercept is what is left. So I have 3 over negative 49, or in other words, negative 3/49. Now, the reason I'm showing you that is because look at the difference between A and D, where they cross the Y-axis. Here's where A crosses. Look, it looks like it's a little below in the Y. Here's my negatives in the Y, right? Down here. But look at this one. Where is it crossing the Y-axis? a little above the origin, which means it's y-intercept. I don't know what it is, but that's definitely crossing the y-axis above 0, which means it can't be crossing at -33/49. That's why I chose the A one, because it was crossing the y-axis below the origin, which means it was negative. Okay, so we did 3. We've done all the way through 13. So now we're going to 14. All right, 14, the function is f of x equals 3x plus 3 over x. All right, the first thing it's going to ask me is, what is the domain? Okay, again, you got the notes, refer back to them. Domain means to find the 0 of the denominator, because I need to leave that number out of the domain. And then my domain will be all the other numbers. So when I set this equal to 0, I don't even have to solve anything. It's already got the x by itself. So what can x not be? It cannot be 0. So I want to show everything from -infinity to +infinity except 0. So let's see what represents this interval right here. -infinity to 0. And that interval right there would be 0 to +infinity. So there's your domain. Now, instead of doing horizontal and vertical asymptotes, which I'm actually probably going to do to be able to distinguish, it asked me to find the X-intercept. So if you look at your chart or your notes, the X-intercepts come from zeros of the numerator, as long as they're not also zeros of the denominator. Well, I already know the 0 of the denominator is 0. So let's see what the 0 of the numerator is. 3x plus 3. Set it equal to 0 and solve it. So let's see, subtract the 3 from both sides. So 3x equals -3, and then divide by 3. So x equals -1. So is -1 a good x-intercept? In other words, it's not the same as the 0 at the bottom. So it is an x-intercept. Now remember, x-intercepts are a point, which means it's an ordered pair. What you just found to be is the x-coordinate. And what is your y coordinate always at your x-intercept? It's 0. So your x-intercept is at -1, 0. Now your y-intercept, I'm going to have you add a little phrase to this too. Because on here, the y-intercept says the graph is going to cross the y-axis at the number that is left after you replace all the x's in the function with 0. Okay, now if I replace all the x's in this function with 0, what do I have? 3 times 0 plus 3 over 0. So I replace the x's with zeros. What does that give me in the top? 3 times 0 is 0. Plus 3 is 3. 0 in the denominator. Here's what I want you to add to the y-intercept note. If, when you replace all those x's with 0, if that turns your denominator into a 0, that means there is no y-intercept. right? Because what is this number? If you try to figure out what that number was in your calculator, it's going to give you an error message, because what can you not divide by? You can't divide by 0. Okay, so if you replace all the x's with zeros in your function and it turns your denominator into 0 like it did on this one, then there is no y-intercept. So let's see. I've answered all the questions that are in this problem, but I don't think it's going to get me all the way to the correct multiple choice. Let's see. It crosses the x-axis at -1. I don't know, I might. So looking at this one, A does look like it crosses the x-axis at -1. But look where this one crosses the x. Here's 0. If it's going this way, that's positive something. So that's why it's not B. That one I'm not for sure, but it looks like it probably crosses through right at 0. And this one crosses through on the positive side also. So that's why it's not D. So I know it's not B, I know it's not D. I'm thinking it's probably A because that crosses through. It looks like at -1. Okay, another reason I know it's not this one, because what do we know about the y-intercept? There's not one. There is no y-intercept, which means this graph doesn't ever cross the y-axis. Look at this one right here. What does it do right there? Here's my y-axis. And there it does, crossing it right there. So that's why I know it's not that one. This graph doesn't ever cross the y-axis. So that's why you knew it was A. All right, now 15, 16, 17, and 18 are all going to ask me every single possible thing we have learned about rational functions. Okay, so starting with domain, it's going to ask you about the x and y intercepts, then it's going to ask you about the asymptotes, and then it's going to ask you to choose to show which graph it is. Now, the first thing I'm going to do on all of these, because it answers a lot of the questions for me. Because when you're finding zeros of the denominator, what's that going to help you with? That's going to help you with the domain, right? Because the zeros of the denominator need to be left out of your domain. It's also going to help you find the vertical asymptotes, because those vertical asymptotes are also zeros of the denominator. It's just as long as they're not zeros of the numerator. I'm also going to start off by finding the zeros of the numerator for 2 reasons. I need to make sure they're not the same as any of the zeros in the denominator. But that also tells me what the X-intercepts are. So on all 4 or however many more of these questions we have, the very first thing I'm going to do is write out what the zeros of the denominator are and also the zeros of the numerator. So let's look at number 15. My function is f of x equals x plus 3 over x squared minus 9. So just like I said, I'm going to find the zeros of both. So let's see, up here, x plus 3 equals 0. Where do I want to do that? I'll do it up here. Solve that for x to find its 0. So I'll subtract the 3. So x equals -3. So I'm just going to write this up here in another color. -3 is the 0 of the numerator. Now I'm also going to find the zeros, right? There's multiple since it's squared of the denominator. So I'm either going to factor that. It's a difference of squares. They're both perfect squares. Or I could take it to quad since it's squared. Let's see, x and x for x squared. What's the number I'm going to put here? It's going to be the same number. And when I multiply it together, it's going to give me 9, which would be 3 and 3, 1 plus and 1 minus. Set each factor equal to 0. And solve them for x. So this one, I'd have to subtract the 3 from both sides. So x equals -3. And this one, I'd have to add 3 to both sides. So x equals positive 3. So those are the zeros of the denominator, negative 3 and positive 3. Again, I'm just going to do that legwork up front because it's going to help me with the questions. The first question is going to be, what's the domain? Now remember, we've already found the zeros of the denominator. That's what helps me with the domain. I need to leave those numbers out of the number line on the domain. So let's see, I'd start at negative infinity, all the way to negative 3. Then the middle interval would be the numbers between those. So negative 3 to positive 3. And then the last one, positive 3 to infinity. So there's your domain. All right, the next part of the question is asking you about the X-intercept and Y-intercept. So let's see, the X-intercepts are, this is why we did it, the 0 of the numerator, as long as it's not a 0 of the denominator. But look, it is. These are the same, which means the X-intercepts are, again, the definition is zeros of the numerator as long as they're not zeros of the denominator. So since this is a 0 of the denominator, that means like it cancels that, which means there are no X-intercepts. The Y-intercept is what is left after you replace all the X's in the function with zeros. What I like to do, because what happens if you replace an X with a 0? It just knocks out its term, doesn't it? So just picture what's left when you cover up the X's. You've got 3 over negative 9. So if I reduce that, it'll be negative 1/3. Now remember, intercepts are ordered pairs. It's the Y-intercept, so the number goes in the Y spot, the zero's in the other spot. So there's no X-intercept. The Y-intercept is at 0, negative 1/3. And the last thing it's going to ask you are the vertical and horizontal asymptotes. Now remember, vertical asymptotes, I go back, they're zeros of the denominator that are not also zeros of the numerator. So this one is not a vertical asymptote because it's also a 0 in the numerator. So the only vertical asymptote is x equals 3. And the last thing it's going to ask you is horizontal asymptote. That's where you look at your chart. What's the degree of the numerator? It's 1, because that's its highest exponent. The degree of the denominator is 2. So the numerator's degree is less than the denominator's degree. What does that mean in your horizontal asymptote chart? Less than means the horizontal asymptote is automatically y equals 0. Now, when you're choosing multiple choice, the first thing I always look for is the vertical asymptote or asymptotes. Whereas this one, x equals 3. So there should be a dashed line at positive 3 on the x-axis. That's going to help you narrow it down. Because, actually that gets you all the way there. Because look at B and C. They both have 2 vertical asymptotes. One here and one here on both of them. Your vertical asymptote should be at +3, which that's where this one is. See, it's going through at +3. Where is this one going through? At -3. So that's why it'd be A. A is the only one that has this distinguishing vertical asymptote. $16. So again, I'm going to write the function up here, and then I'm going to find the zeros of the numerator and the denominator. All right, the function is x squared plus x minus 12 over x squared plus 6x plus 8. They're both quad, right? So I'm going to, I don't know why I put parentheses around that. I'm going to find the zeros in the top and the bottom by using quad. Up top, my A is 1. My B is also 1. And my C is -12. So 1, 1, and -12. So the zeros of the numerator are 3 and -4. Now I'm going to find the zeros of the denominator using quad also. So A is 1, B is 6, C is 8. So 1, 6, 8. And it gave me -2 and -4. So the zeros of the numerator are 3 and -4, and the zeros of the denominator are -2 and -4. All right, just like the last one, it's going to start off with domain. Again, this is why we do this beforehand, so that we can just use it going through the question, right? The zeros of the denominator make my domain. I need to leave these numbers out of my intervals. So where does the domain start? At -infinity. Be careful here. On the number line, if this is -infinity, who are you going to run into first? You're actually going to run into -4 first, and then -2, and then go to infinity, right? Because -4 is closer to -infinity than -2 is. So let's see, this interval is -infinity to -4. What's the middle interval in between these? So -4 to -2. And the last interval is positive, or not, excuse me, not positive, -2 to infinity. So there's my domain. All right, what is the x-intercepts? Again, now we're going x-intercepts and y-intercepts. X-intercepts are the zeros of the numerator, 3 and -4, as long as they're not always also zeros of the denominator. So which one of these is not a real x-intercept? The -4 isn't, because it's also a zero of the denominator. So the only x-intercept is at +3. When you type it in, you have to type it in as an ordered pair, 3, 0. The y-intercept comes from replacing all the x's with zeros. So the way I like to do is just look at this function without any of the x terms, any terms that have an x. So essentially, you're just looking at this over that. Those are the only terms that don't have an x. So they wouldn't be knocked out with zeros. So -12 over 8. Let's see what that gives me. I'm just going to type it in. Negative 12 over 8 in my home screen. It's going to give me a decimal. So just math, enter that decimal. Negative 3/2. So the y-intercept, remember the negative 3/2 goes in the y spot, the zeros in the x spot. So there's your y-intercept. And then it's going to want to know vertical asymptote, horizontal asymptote. So let's see, the vertical asymptote, zeros of the denominator, but that are not also zeros of the numerator. So since negative 4 is in both spots, it does not make a vertical asymptote. Your only vertical asymptote is x equals negative 2. Now your horizontal asymptote, that's what goes with the horizontal asymptote chart. The degree of the top compared to the degree of the bottom. In this case, they're both 2, which means the degree of the top equals the degree of the bottom. In that case, you look at these coefficients that are both 1s. This right here is where your horizontal asymptote is. 1 over 1, which is just 1. So y equals 1. And then there's not an oblique, right? It's always going to ask me that, and I'm always going to say there's not one. So here's what I'm going to go with when I'm choosing. The very first thing I'm always going to look for, just because I know, or I hope it helps me, is where the vertical asymptote is. This one is at negative 2. So vertical at negative 2. So let's see what that knocks out. It knocks out C and D, because look where theirs are. They're verticals, but they're both at positive 2. A and B both show the verticals at negative 2. But look at the horizontal. Look at this one. It's going above the x-axis, so it's in the positive area. This one is going below. See this horizontal one? It's going below. So what is my horizontal asymptote? It's at y equals positive 1. So it is right there, which that's why it would be that B one, because that one's the one that had the positive horizontal asymptote. All right, next one, number 17. There's just 2 more. F of x equals x minus 4 over x plus 2. All right, let's find the zeros of the top and the bottom. Look, they are just x's, which means each one of those is just going to have 1 0. Okay, let's see the denominator. What makes it equal to 0? Let's solve it for x by subtracting the 2 from both sides. So x equals negative 2. So negative 2 is the 0 of the denominator. What about the numerator? X minus 4 equals 0. Solve it. Add the 4 to both sides. So x equals 4. So the 0 of the numerator is 4. And the 0 of the denominator is negative 2. So 4 and negative 2 are my zeros. first thing it wants to know is what's the domain. The 0 at the top was 4, the 0 at the bottom was -2. So the domain, where does that come from? The zeros of the denominator just need to be left out of your domain. So I want to say all the numbers below -2, which is -∞ to -2, and all the numbers above -2. So -2 to +∞. Let's see, where are the intercepts? The X-intercept is the 0 of the numerator, as long as it's not also a 0 of the denominator. Are those the same? No, which means that is an X-intercept. So it's going to, remember to enter it as an ordered pair. This goes in your X spot, the 0 is Y. The Y-intercept, just cover up your X's, and what's left? -4 over 2, which reduces to -2. So the Y-intercept, the -2 is in the Y spot, 0 in the X. Last two things, vertical and horizontal asymptotes. The vertical asymptote, 0 of the denominator, as long as it's not a 0 in the numerator, and it's not, right? So X equals -2. And the horizontal one is when you use your horizontal chart. How do the degrees compare to each other? They're both 1, which means they're equal to each other, which means you use this number that's in front of there to make a fraction. What is it if my box is empty? I don't see the number. It's 1 over 1, which makes it Y equals 1. So the first thing I'm going to look for in my graph are these right here. There's a vertical asymptote at -2 and a horizontal asymptote at Y equals 1. So it looks like A and D are knocked out because of their vertical asymptote. They're both at +2 instead of -2, right? This one's at +2 and that one's at +2. So we're down to these two. And you'll notice the difference is where their horizontal asymptote is. This one's at +1. This one looks like it's probably at -1. So where does the 1 need to be? It needs to be up above the origin at +1. So that's why it would be the B. So it would match both of those. All right, last one. F of X equals X squared plus 6X. Over 2X to the third minus 11X squared minus 6X. So I'm going to find zeros first. Okay. Now, what I notice is that the denominator is going to have 3 of them, right? That's what X to the third means. Is I'm going to have 3 zeros. To find the first one, I noticed that they all have an X. So I'm going to pull that X out, put in parentheses what is left. So let's see, if I took an X out here, I still have 2X squared minus, if I took one of these X's out, I still have 11X minus, if I took that X out, I still have 6. So this right here, this is going to make one of my zeros. This is going to make the other 2 zeros, right? Because it's quad now. So let's find it using quad. So go on down to program, with your program button, down to quad. Hit enter. And your A, B, and C. My A would be 2. My B is -11. My C is -6. Decimal, so 6 and -1/2. So 6 and -1/2. Okay, the zeros of the numerator. Let's see. This also has an X in common. So if I pull its X out, what's going to be left with each of these terms? X plus 6. And I could have put that in quad. So let's see. This X, if I set it equal to 0, it's already solved. So there's one of the zeros. What's going to happen to this? If I set X plus 6 equal to 0 and solve it for X, what would I have to do? Subtract that 6 from both sides, which would make what? X equals -6. So the zeros of the denominator are 0, 6, -1/2. The zeros of the numerator are 0, so we need to be careful about that. That's when you say, okay, I need to remember that in the problem, because that's going to affect it, because they have zeros that are in the top and bottom, and -6. Now, the domain on this one is multiple choice. The domain, you just need to leave all of those numbers out, right? X can't equal any of those numbers. This one kind of goes a different way. It goes vertical asymptote, horizontal asymptote. What are vertical asymptotes? Zeros of the denominator. So I'm looking at these again. They're not, are not. Also zeros of the numerator. So 0, this right here, since it's a 0 in the top and the bottom, that means it's not a vertical asymptote. So these are your only vertical asymptotes. X equals 6 and -1/2. Horizontal asymptote, let's compare. The degree of the top is less than the degree of the bottom. When you're looking at your horizontal asymptote chart, when the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is automatically at y equals 0. All right, X-Intercepts. Zeros of the numerator, so it's 0 and -6. Oops, I just knocked it out. That are not also zeros of the denominator. So which one of these is also a 0 of the denominator? This 0. So its X-intercept is at -6, 0. The Y-intercept, which means cover up every term that has an X and see what's left. Well, what happens here? If I put a 0 in all those, it's going to knock everything out, turn my denominator to 0, which means there is no Y-intercept. Now, on this one, it's hard to tell, even from all this information, which one it is, because remember, our go-to is to go to vertical asymptotes first and look at every single one of them. They all have vertical asymptotes at 6 and -1/2. That one's going through at 6. That one's going through at -1/2. Same here, and same here. So no help. Y equals 0. They also have that, right? Y equals 0 is a horizontal asymptote that's just lying on top of the x-axis. So they all have that. The next thing is, let's see, what else do I know? I know that the X-intercept is at -6. which is very hard to tell. And there is no y-intercept. That's going to knock out two of them, right? No y-intercept means the graph does not cross the y-axis. Look what it's doing right there. There's my y-axis, and there it is crossing it. This one too. Here's my y-axis, and there it is crossing it right there. So here's the distinguishing mark. This one, look, it doesn't cross the y-axis because it has what's called a hole. Same thing here. It doesn't cross the y-axis because it's got that hole in the graph. So now here's what you want to do to find out which one that is. One of the holes is at -1 and one of the holes is at +1. The way you find where the hole is, you remember that factor that made the same 0 in the top and the bottom? That's going to be the x-coordinate of the hole. So what was that number that we saw in the top and the bottom? 0. The y-coordinate, so what factor made this? 0. Then cross it out. What factor made this 0? This one. So cross it out. So what are you left with? Up top, if you took out this x, you're just left with the x plus 6. In the bottom, if you took out this x, you're left with this. 2x squared minus 11x minus 6. This is to find the y-coordinate of the hole. The x-coordinate of the hole is this number that was in the top and the bottom that was the same 0. So that's why the x-coordinate is 0. The y-coordinate is what is left here after you take out all the terms with x's again. So if you replace all those x's with zeros, it would knock this out and those out. So what would be left if all the terms that had x's disappeared? 6 over -6, which is -1. That's the y-coordinate of the hole. That's the difference, the distinguishing feature that's between A and D. Look where A's hole is, down at -1, and look where D's is, up at +1. So that's why that one is A. So you may want to add those whole notes to be able to do number 18 to the notes for 8.5, okay? To find the hole, the x-coordinate of the hole is the 0 that's same in numerator and denominator. That gives you the x-coordinate of the hole. So since the 0 that was the same in the top and the bottom was 0, the y-coordinate comes, that's when we found the y-coordinate over there. That's where, after we took out the factor, which were these x's that made those zeros, what was left, which was x plus 6, and then 2x squared minus 11x minus 6, and took out all their x terms. And what was left? +6 over -6, which reduced to -1. That's what gave me the y-coordinate of that hole. So you're going to have that knowledge to do number 18. Okay, it is 1:30, so I'm going to jump off this one and jump over to the support Zoom. Oh, after I take roll. Hang on.